Hello. Prove that the sum of three consecutive integers is divisible by 3. Well, let's use n add 1 to indicate one of these integers. Now if n is 1, then this will be 2. We could also use, for the next, n add 2. So in this case, if n is equal to 1, this will be equal to 3, and so on. So we have 2, 3, and n add 3. So these are three consecutive numbers. These represent all consecutive numbers. If we substitute n in any one of these expressions, we'll get an integer, and there will be consecutive integers. So we'll add all of these, and this will give us 3n, add 6, and to show that it's divisible by 3, we factorize this expression. 3 into n, add 2. And this shows that the sum of three consecutive integers is divisible by 3. Next, we have proved that n add 6 all squared minus n add 2 all squared is always a multiple of 8. Well, we'll just try to expand this and see what we have. Expand n add 6 will give us n squared. Add 2 times the product of n and 6, that's 12n. Add the square of this, which is 36, minus, and we'll square n here, give us n squared. 2 times the product of n and 2, which is 4n. Add the square of 2, which is 4. We'll clear the brackets. N squared add 12n, add 36, minus n squared minus 4n minus 4. Now, the n squared cancels with a minus n squared. That goes to 0. We have 12n minus 4n will give us 8n. And then we have 36 minus 4 will give us 32. And to show that this is always a multiple of 8, we factorize by 8. And this shows that n add 6 all squared minus n add 2 all squared is always a multiple of 8. Right, we're asked to prove the sum of two consecutive odd numbers is even. In proof, we always use 2n add 1 to indicate an odd number. So for instance, if n is equal to 0, then this would be the first odd number, 1. And if we use the next odd number to be 2n add 3, here this will be equivalent to 3 if n is equal to 0. So these are two consecutive odd numbers. Well, they represent that. And we'll sum these. And this is what we have. We have 2n add 2n, which is 4n. Add 4. 3 add 1 is 4. To show that this is even, we factorize by 2 to give us 2n add 2. This indicates that this expression will always be even because it's multiplied by 2. And this finally proves the sum of two consecutive odd numbers is even. Here we have, to prove that the sum of three consecutive even numbers is always a multiple of 6. Well, we start with the first even number, it's 2n. The next will be 2n add 2. You can try this, you can check this, substituting any value for n, any positive value for n in any one of these expressions. And the third would be 2n add 4. So these are three consecutive even numbers. We need to show that the sum of these is always a multiple of 6. So we have 2n add 2n add 2 add 2n add 4. This is equal to 6n add 6. And if we factorize, we can see that the sum of three consecutive even numbers is always a multiple of 6. Right, what if we have to prove this equation? Well, we'll start with the left-hand side and see if we can prove that it's equivalent to the right-hand side. We'll clear the brackets. We have n squared add 2n add 1 add n squared add 6n add 9 minus n squared minus 10n minus 25. So this is our left-hand side. We've expanded. Now we'll simplify this, bring together all the n squares. We have this now is equal to n, look, we have how many n squares? 1, 2, take away 1, which will give us just n squared. We have 2n, 6n, which is 8n, minus 10n will give us minus 2n. No. Gives us minus 2n. 1 add 9 is 10. Take away 25 will give us minus 15. So this is our quadratic expression. And when we look at the right hand side, it looks like a quadratic expression that has been simplified or factorized. So let's factorize this. We have a is 1, c is negative 15, so our product is 1 times negative 15, which is negative 15. Two numbers when multiplied will give us this is minus 5 and positive 3. When added will give us negative 2. So we'll factorize this by writing n squared minus 5n add 3n minus 15, which is equal to, we factorize again, n into n minus 5, add 3 into n minus 5, which is equal to n add 3 is common to n minus 5. So this shows that we've proven what's on the left hand side here is equivalent to what's on the right hand side. That's all for now. If you like these videos and you'd like to see more, like, share and subscribe. My name is Alistair.